Welcome to solverfy.
Okay. In this problem, we really have a discussion as to why helium ions are used in this particular microscope. We have four options. We have, in the first option, the case that is made is that only charged particles can be wave-like. The second option, we have the statements essentially saying that helium will form molecules which will be too large. The third option is that helium ions can be easily manipulated by E and B fields, which is advantageous. And option D is that helium atoms, the neutral atoms, will be more massive than the ions. So we can actually arrive at the answer through process of elimination. So to start, let's look at option A. Only charged particles are wave-like. That's not true, because one can easily look at the definition of a de Broglie wavelength. MV equals h over p. You see it all depends on momentum. There's no reference to charge anywhere. It depends really on mass. The more massive a particle is, the less wave-like it'll be, unless it's moving faster. So we can throw that out immediately. Option A is no good. Molecules will be too large. Well, this would reduce the wavelength, but I strongly would suggest that molecules formed by helium atoms would not be that much larger than the helium atoms themselves. In a world where our quantities vary by many, many orders of magnitude, I don't think one order of magnitude change to form these molecules would make much of a difference. Option C is the correct answer. So I'm going to skip over it and talk about this last wrong answer, option D. The helium atoms are more massive than the helium ions. This is not true, because ions are formed when you pull electrons off the atoms. Electrons, compared to the nucleus of the atom, the mass of the electrons are almost insignificant. It's a 4 or 5 order of magnitude difference. So whether this helium has electrons or not is going to make very little difference to its total mass. So that's out. Option C is the correct answer. The reason why we would want to use helium ions instead of neutral helium is because an ion has a net electrical charge, so it can be manipulated by E and B fields. The easiest way for us to manipulate matter is to use its electrical properties. This is always the case, and this is the case for this problem. So just to recap, for option A, uncharged particles can also be wave-like because it only depends on mass. Option B, molecules are not going to be that much larger to make a big difference. Option D, atoms and ions of the same element are going to have insignificant mass differences. Option C is the correct answer.